Hi, CivilBay concrete anchorage users. Um, that's tutorial 2 for concrete anchorage. In this tutorial, I'm going to show you two examples how to use this program to design the concrete anchorage, base plate and shear key. All right. So there's a working sheet, and I will put the working sheet on these same page as this video link, and also in the YouTube's description area. You will find a download link for this working sheet. Okay, so basically it's a PDF file. There are two examples. One is these examples. Okay, the other one is from ACI campaign companion books volume 2. There's another example here. Today I'm going to run these two examples pretty much to show you how to use our program to design the anchorage, and after that you will be expert on this one using this program. So download the PDF file from the link coming with this video. Follow these videos either on our website or on YouTube description area. There's a link for downloading this working sheet. It's a PDF file. Okay, so I will move this PDF file out to the second screen. So I assume you open this PDF file and go with me step by step on that, because there's only one screen for recording, so I can only move it out. Okay, move it out. So now we're going to do the example one first. That's the detail is 4 bolt pins with pipe shear key. There's two load cases. One is compression and shear load. One is tensile uplift with shear load. Okay, that's a real project. So move this out. Look at the PDF file yourself. So first things we select code, design code. We only need to do this once. Okay, American ACI 19 in period, design unit in period, and display unit as fractions. Okay, we hit OK. And second things, probably you go to change your company name and project names, connection ID here. We are already on Anchorage. Okay, switch to concrete. So we switch back to dimension. Okay, the spacing of these okay, the spacing of this one is 10 inch by 10 inch. I think it's 10 inch by 10 inch, and the edge distance is 10 10 13 13. Okay, so we do that. It's a 10 inch. Okay, oh no, first of all, sorry about that, we had to change the bolt pattern. Okay, that's 4 bolt pins, and we also had to update the column size to 1886. Okay, 1886 column size 18 and 86. Okay, so 18 and 86. Okay, so 1886 and the bolt pattern. So you see to the arm, the bolt patterns, you know what's going on. There are all kinds of bolt pattern. Now what we want is 4A. Okay, 4 bolt pins, 4A's. I turn it off. Okay, so select 4A. Now it's 4 bolt. Okay, so 1886 4 bolts. Now bolt spacing 4/8 1886. Bolt spacing is 10 inch. Okay, C1 is 13 inch, C2 is 10 inch, C3 is 13 inch, C4 is 10 inch. Okay, embedment depth is 20 inch, and HA pedestal height is 40 inch. Okay, and concrete strength, let's say for KSI, update it. Okay, update all of them. Okay, update all of them. These base plate edge distance, switch to base plate. Okay, base plate, where is it? Base plate is here. Horizontal is 3.5. Horizontal edge distance in terms of base plate edge. Okay, not concrete edge 3.5. Vertical is vertical edge distance is 5.5. Okay, so I'll show you. Horizontal 3.5, vertical 5.5. Okay, 3.5, vertical 5.5. Plate thickness is 2 inch. Okay, plate material is let's say now grade is 572, let's say A36. Okay, you want to change A36 base plate grade. Okay, so now change to A36. So now we are close to this guy. Okay, we are close. Then next we change the bolt. Bolt is for 1.5 A320. For 1.5. Give me a second. Okay. Go to dimension. For 1.5 A320. Okay. A320 1.5. Okay. Now there's a shear key. Okay. Alright. There's a shear key. It's pipe 8.625 multiply 0.625 shear key and grade C. Okay, so we go to shear key. Where's shear key and shear lag? Okay, and provide shear key, yes. Okay, and these it's pipe 8.625 and 0.625. Okay, and the grade is C. Okay, so grade C FY46. Okay, grade C, material shear key, material strength, grade C, right? Okay, and the pocket size, what is it? Pocket size, it's 14 by 14. The depth is 9 inch, and the shear key depth is 8 inch. Okay, the ground is 1 inch, so 14 by 14 multiply 9 and 8 inch first. Okay, 14 shear key that's 8 inch, 14 by 14 by 9 inch pocket depth. Okay, so now that's CJP weld. Okay, where is it? CJP glue weld. Okay, I think we are done with shear key, and we are done with the shear key. See here, side view. Okay, we are done with the shear key. So now the design load. Design load. You can. Okay, so two load cases. Okay, first is compression 545, shear 175, and the next is uplift 85, shear 175. Okay, so we set everything to 0 first, and compressions 545 keeps 545, and 175. Is it 175? It's a very big shear. Uplift is minus 85. Again, it's 175. Very big shear force. Okay, very big. So, why? It's 4.86 fair. Okay, 175. Okay, that's because we need anchor reinforcement. Okay, already provide anchor reinforcement. Then why there's such big failure here? So 4.86. Okay, let's see. We turn off the sketch, and we disregard all. We keep summary and where it's going on. Shear key LC1, shear key LC1, 4.86. Anchor reinforcement breakout. I know. Okay, so that's a big shear, and the shear key breakout. Okay, to 3H, and we need more tie bar. Okay, so that's a pedestal. That's huge shear of 175 kips. It's very huge shear. Okay, and the anchor reinforcement. If without using anchor reinforcement, it won't pass. We use anchor reinforcement. Okay, consider horizontal tie to resist the breakout force, and even that is not adequate. We increase the tie diameter, increase the layers, let's say 3 layers, and we have let's say 3 legs, 6 legs. Okay, it passed. Okay, so let's increase the leg, increase the layers. We have how to say that. I will explain to you. Okay, I'll explain to you on another example. Okay, like this one. We increase okay, like this one. We increase the one to how to say this. We change to number 5 ties, number 5 bars. We increase the leg 1, 2, 3, 4. We probably add 2 more, 6. Okay, 1, 2, 3, 4, 5, 6, and we increase the layers like 2. We use diamond ties. We use 4 legs. Okay, and we also 3 layers dams confined within this area. That's how we increase the leg number and layers. All right. Oh no, layer is 3. leg is a 6. Okay, it's the same. So no, layer is 3. It's a leg. Okay, tie leg. Yes, leg is 6, layer is 3. So basically we use diamond, we use 4 legs, put 2 additional legs, and diamond. There are 6 legs in total and three layers with close spacing. Then we increase this area and we get this design pass. Okay, get the total at the 0.7. Okay, so that's one of the example of calculations. Okay, calculations. We select all. Okay, we have 2 low cases. Okay, select all. We probably expand all. Okay, we hit the print buttons. Okay, so we have a summary, we have sketch, plan view, and 2 locates. One is compression shear, one is tensile shear. We have anchor force calculations. Okay, so these are detailed calculations, everything you can print out. Okay, refer to tutorial 1 on how to print it. So we will go to the next example. This all. We finished the design of this example. The first one. Okay, the first one. Okay, the first one with 4 bolts with shear keys. Then we'll go to the next. Is from ACI document, companions, ACI manuals, volume 2, example 110, example 21. Okay, so that's it. Again, it's a pedestal. I highlight this parameter here. It's a pedestal, and now we go to that. We are going to input spacing 16, 16. Okay, first we change to bolt pattern to be like this. Okay, it's 4 bolts. Okay, now go to dimensions. The 4 bolts. It's like this. Okay, 4B. All right, we change it to 4B. We are now at 4A. We change it to 4B. Close this one. 4B, 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 4B. Where's it? 4B. Okay. And no shear key for now. For this one, no shear key. Okay. Now the column size is column 1468. Okay, 1468. Column size 1468. So I will not move the PDF in and out to save time. I will not move this PDF in and out. So all you can do, you have download this PDF file, working sheet. You put your PDF on your own screen. Okay, I will not move this in and out to save time. I just grab data from that PDF and keep input it. We already changed the column. Now the spacing is 16 by 16. 16. It's 16 already. And the edge distance in terms of concrete edge is C1, C2, all 6 inch. Okay, so 6 inch, 6 inch, 6 inch, 6 inch, and Batman depth is 18, and HA 18. Okay, and this one is 45, and concrete is 4.5, Okay, it will update. The bolt grade is okay. The base plate edge distance to the base plate. EV, where is it? Okay, 2.5. Okay, 2.5 inch. 2.5. Base plate thickness is 1.5. Update. Okay, and the base plate material A36, it's already there. Yep. So I put this one. So colon, everything set. The bolt, go to dimension. The bolt is for 1¼ inch. Okay, edit, change bolt F1554 grade 55 1¼ inch. 1¼ inch. All right. Okay. All right. So we pretty much input everything. We pretty much input everything here. Okay. We input everything here. Now we have a load tensile 116. That's okay. That example show you how to combine it. We don't care how you combine it. We only care about the final factor value. Okay. How you combine it, it's your business. Okay. Because different engineer, different code, they have different load factors. We don't want to be involved in that. We only care about the final factor value. Factor tensile is 116, the ultimate value. Okay, the tensile is 116 and the shear is 30. Okay, so tensile, go to design mode. Okay, so first things, we clear everything to 0. Okay, so we don't have load case 2. We have only one load case, is tensile 116. Okay, the shear is 30. Okay, update. So 1.31 is fails. Okay, we already use anchor reinforcement, I think, for whatever reason fail. Okay, we examine it. Summary. But okay, it's anchor load case 1 fail at this one. You can compare to the shear interactions. You can compare to these this calculation. Okay, you will see. As I say, you play the program against these example. You know where it fails. Okay, and then after that, you say probably use shear key to get it passed. Okay, 24. I think it's 24 somewhere. Use shear key. Okay. Let's see. Now, it propose. Okay, what's the? There's one bad thing is shear key. Use anchor reinforcement and the grout thickness. Okay, the example is 3 inch, which is 3-inch grout. Okay, normally we don't do that. That's huge grout. I think one inch grout is adequate. Alright, even 1-inch grout, it fails. Now that example, say we use shear key. Okay, it's a plate shear key type. It's 7.5 inch wide, 6-inch depth, 1.5 inch thick. It's a cross plate. Okay, so we will do that. We provide shear key. Okay, yes. and the now we use a cross plate, and you see we drop it down, 7.5 wide, 1.5 thick, and 6-inch depth, and pocket. Let's do it. Update. Pocket size. What's the pocket size? Let's do 12 by 12. 12 by 12. Okay. And 7-inch depth pocket. Looks good. All right. So that's it's 1.5 inch thick. Yeah, that's correct. Should keep it 1.5 inch thick. Fitting weld. Let's say CJP weld. Okay. It's close. That one is because let's check key only. Okay. Dimension check. There's something wrong here. The embedment depth is not adequate. So there's a code. You refer to the code. Okay, you will know what's going on. They avoid the overlap or the stress. They want this one go deeper. Okay, so now to get this passed, we have to increase the embedment. Okay, 22, 25. Update. Now we get warning message. Okay, warning message is kind of tolerable. Okay, we allow it. Just kind of reminders for non-code compliance. Okay, so basically it's a PIP standard, and that's PIP. That's optional. Okay, edge distance is too small. That's not code requirement. It's PIP. If you don't like it, you don't care about it. It's non-code compliance. You can turn it off. Okay. Go to config and settings. I don't want this check. Okay. So check minimum edge spacing as per PIP. Yes, I change it to no. The warning message will turn off. Okay, so now let's see what's 1.8. It's base plate. Okay, again there's a kind of non-code requirement. We see base plate minimum thickness to be a minimum thickness to be 1/4 of the overhang. That's not a code requirement, and we want the base plate to be rigid. If you like it, you keep it. If you don't like it, you turn it off. It doesn't matter. Okay, nobody will dispute you on that, because it's your own provisions to make sure the base plate is rigid. Okay, so that one, I don't want this check, and you get it passed. Okay, so the design passed. All right, so here we finished the two example. Okay, preview, design, sketch. Okay, I take so long. Okay, and print. Okay, let's share key. So we give you step by step on how to design these two examples. One is this, one is that. Pretty much you are an expert on the program now. Okay, that's very easy program. easy to use, and lots of graph. It's the best Anchorage program in the world. Okay, we appreciate your attention on this program. Thank you very much.